So this talk is Git Workflows, the Little Red Riding Hood, and the Big Bad Ogre. There is a rather influential essay or blog that is Git Workflows. And that talk focuses more on the higher abstractions of the higher level thinking and processes with Git. And this talk focuses more on the details of working with Git. So I probably should have renamed this presentation to Git Micro Workflows, the Little Red Riding Hood and the Big Bad Ogre. So to tell you a little bit about myself, my name is Travis Douce. Here's my contact information, Twitter and GitHub. And I work for a company in Atlanta, Georgia called the Big Nerd Ranch. I work remotely in Athens, Georgia, which is, for those of you who aren't familiar with the geography of the area, is about an hour east of here. So at Big Nerd Ranch, we do three things. This is a shameless plug for a Big Nerd Ranch. We teach, we develop, and we write. So we teach iOS 8, Swift, Objective-C, OpenGL, and design for iOS. And these classes are also taught in Spanish. We teach classes in Android, also design for Android, also in Spanish. And we do backend web, Ruby, and Python. I primarily write in Ruby on Rails every day. We do front-end web, JS, HTML5, JavaScript 3, and we also do Mac and Cocoa and iOS and OS X internals. So we develop on all these platforms. If the teachers, if they're not teaching or writing a book, which we'll learn in a little bit, they're developing, so their skills are sharp and they have real-world experience. So we also write books. Here of a few of the books that we have written on Objective-C, OS X programming, Android programming. These two are #1 on Amazon. So enough about Big Nerd Ranch. And again, this talk is about Git. Just curious, who has experience with Git at all? Would you say you're beginner? Raise your hand if you're beginner level. Intermediate? Okay, and then, okay, fair enough. So hopefully you'll get something out of this. So what we will discuss in this presentation is what is Git, and then we'll look at creating a Git repository, and we'll look at some very basic workflows in Git. And then we'll spend a lot of time looking at Git history because my feeling is that if you understand how to interpret Git history, then you could create a very strong mental model of Git. If you have a good mental model of Git, you could use that to your advantage and leverage Git's power rather than Git being something that you're afraid of and hesitant to use and being scared of, which I have been in that situation before. And we'll look at a tool or a command called Rebase, and we'll look at branches, and we'll look at merging branches with some different strategies, and we'll look at remotes, which allow us to collaborate with other users in physically different locations. So first off, what is Git? Git is version control. So what does that mean? It's a system that records changes to a file or a set of files over time so that you could recall specific versions to that file at a later time. Branches are a core concept to Git. Okay, so also version control is an idea or a process that cuts across programming languages. So it's not specific to Java or Ruby or Scala or whatever. Git and version control can be applied to all those languages. So Git is distributed. For those of you who are new to Git, I'm asking another question. What other version control systems or tools have y'all used? Like Subversion, MCAS, Mercurial? Okay, so Git is a distributed version control, and I don't know a lot about Subversion, so I won't speak about it. But what distributed means is that every user of the Git repository has a complete copy of the repository on their local machine. So so commits are made local to your machine, so commits are fast, and then later you could push them up to a remote or perhaps like a central server or repository if you want to think of it that way. So it also makes accessing file history very, very fast because you're accessing it right there on your local machine. Git is fully functional when you're disconnected from the network. So I think the canonical example is like, hey, what if you're on a train and you don't have any internet connectivity? you could still work because you have the repository on a local machine. You can make commits locally, and then when you get connectivity again, you can push it up. My problem with that example is I know few Americans that ride trains. Kudos if you do. For me, it's when I lose internet connectivity at home or at my office. There currently is construction going on, so Git has paid dividends for me in the recent days. Okay, so when I'm describing what version control is to individuals who aren't tech savvy or don't come from a computer background, which I didn't initially, I describe it in terms of writing a high school essay or a college essay. And then so what I used to do, of course, I was writing my essay in a Word document, not using version control. And I would create a file. It'd be like essay.doc, and that'd be the initial file. And then inevitably, I would copy and paste that file to the same directory and rename it. And perhaps it'd be essay_intro_1. And then it would contain the intro. Then I'd copy and paste that file, and I have a different version of the intro. And then I'd copy and paste that file, and I'd have perhaps that would be about like the body of my essay. So in short, I was doing very unsophisticated version control. I would end up, with perhaps 50 files on my computer, and each would be different representations of my essay. Version control, I think, at its very simple rudimentary form. We could do a lot better than that, excuse me. And Git is much more sophisticated, and so we'll talk about that. Okay, so the brothers Grimm, they've written many stories together, Hansel and Gretel, Rapunzel, Cinderella, just to name a few. So these two brothers, Wilhelm is the older brother on the left, and Jacob is the younger brother, he's on the right. And they've collaborated on all these stories. However, Jacob, he wants to strike out on his own, and he wants to write The Little Red Riding Hood. In the past, collaborating with Wilhelm has been a disaster because Wilhelm is constantly losing papers, erasing his work, writing over it, and Jacob just hasn't enjoyed it at all. But since then, Jacob has heard of this tool called Git, and he's going to use Git when he's writing the story, The Little Red Riding Hood. And so we're going to follow his footsteps. Okay, so to get started, there are going to be a lot of very specific commands in this presentation, very specific Git commands. So I ask you not to focus on memorizing the commands because you won't get much out of the presentation that way. I ask you to focus on the general workflows that are going on. You could go back and look at this presentation in a few days and look at the specific commands if you're interested. Also, we'll be using Git from the command line. I know a lot of people use Git through a GUI. My interpretation of that is that Git, or using a GUI to interact with Git, introduces a layer of abstraction and indirection, this layer of haziness, that you have to understand the GUI's interpretation of Git to be able to effectively use Git. So I like just to go straight to the heart of it, and we're going to use the command line. Also, this presentation, we are not going to be working with code. We're going to be working with prose. Prose is something that we all understand. It's a lot easier to understand than code. So I think if we were using code, people would spend time and energy focusing on the code rather than focusing on Git. So we'll be using prose. Okay, so the first thing that Jacob does is he has a directory called Fairy Tales. And in it, he creates a Git repository with a command called git init. And you'll see that a Git repository is created in that directory, locally on his machine. And then the next command that he enters is git status. So what is git status? Git status is the heartbeat, the health check of the repository. And we'll be using this command a lot through the presentation, or Jacob will be. So he enters this, and it outputs this text to the screen. And most notably, you see that there is nothing to commit. And this isn't too surprising because at this point we have just created a Git repository, but yet there are no files in it to track. So Git tells us, hey, there's nothing to do. So Jacob creates the file where he's going to be writing the Little Red Riding Hood. And he creates the file, then he enters git status, and the output is this very big blob of text. I bring your attention to this portion, which is Git recognizes that there's an untracked file in the Git repository, And the name of that file is littleredridinghood.txt. So that's a lot of text to visually parse. Git provides you to configure repositories. You could have configurations for a local repository and for globally for like every repository like in your user directory. So anyway, we're going to configure globally to provide output, our color to the output. And yes, this means color. Again, don't focus on the very specific commands. I'm just calling these out to bring them to your attention. So Jacob enters git status, and then voila, the little red riding hood .txt file is in red. So untracked files are going to be in red. Okay, at this point, Git is not tracking changes to this file. So we want to tell Git, hey, pay attention to this file, start tracking it. And then so the command for that is git add, and you give it the name of the file that you want Git to start tracking. And then you enter, and Jacob enters git status again, and then now the file is green. So then this means that the file's in a staged area, and we'll talk about what stage is in a second. And then so now Jacob enters git commit, and that means, hey, we want to commit this file to the repository. So Git takes a snapshot of the file or the files that are the committing. I won't get into the details of that. I think there's a Git internals talk later. So any file that's in the staging area, when you commit, will be included in the commit. So when you hit commit, it opens up a text editor. The default text editor, if you don't have one configured, is going to be Vim, I believe. But you can configure it to use whatever text editor you like, if that's Sublime, Emacs, or TextMate, whatever you like. But the point is, it allows you to enter a commit message, which is a description about the commit. And it also allows you to write an extended description. Perhaps you need more details. Note, these are horrible commit messages. And writing a commit message, there could be a presentation about that in and of itself. So I have a link at the end of the slides to a blog that details writing great and well-crafted commit messages. So anyway, we save and close this, and it outputs this to the screen. You don't need to focus on what this says, but it means that it works. This file's committed, and it is being tracked. So Jacob enters status, and Git says, hey, there's nothing to do. Again, unsurprising, because this file has not been modified since its last commit, and Git says so. Nothing to commit. So now Jacob writes the Little Red Riding Hood story. And the first thing he does is he opens up the littleredridinghood.txt file, and he writes the title and the author. Easy enough to get started. And he saves and closes it, and then Git status, and then yes, now Git is saying, hey, this file has been modified since its most recent commit. And then so we stage it. So again, like, what is the purpose of staging? Any file that you stage will be included in the next commit. So if you have 50 files in your repository and you stage 10 of them and you commit, those 10 files will be included in the next commit. So now Git status, yes, that file is staged, and we commit it. So we're committing all these files, again, to the local repository. It's not going to a central server or anything. Open up the text editor, and we write the commit message. And the commit message that Jacob writes is adds title and author, which is exactly what he did. Save and close it, and that file is committed. OK, so Git status, nothing to commit. Great. We are making, or Jacob is making, really good progress. So the first workflow that we have established is really the basic Git workflow. A file goes from a modified state to a staged state and to where it's committed. And I'll bring up 5 or 6 of these like workflows. Some of them are really pro tips throughout the presentation to really call your attention to the topic at hand. OK, so now Jacob writes the introduction for Little Red Riding Hood. And writing introductions, in my opinion, and Jacob's opinion, is a really difficult thing to do. One moment before we jump. So thinking about code for a second, there's a lot of times when I'm implementing a feature. Let's say a user should be able to sign in. And perhaps I don't know how to do this technically, but I'm exploring. And I might go 3 or 4 different iterations or implementations of that feature. So I suggest for every implementation that you create, you make a commit of that implementation. And the reason is because later down the road, if you have created 4 implementations And then the second implementation is what was the best one. Using version control, we could revert back to that commit and use that one. So the advantage of, this is the alternative to commenting out a bunch of lines or hitting back button 55 times and then to the first implementation and go, oh, I want the second implementation, and hitting forward 30 times and then going back 10 times. So avoid that unnecessary distraction. You're focusing too much energy on that problem where you could use Git to offload that mental energy and focus on the problem at hand, which is writing implementations. Okay, so Jacob begins writing the introduction of the story, and he types, once upon a time there was a little girl. And he saves and closes it because he thinks that's a good introduction. And he enters Git status, and the file is modified. And then he stages it, and then he enters Git status again. Yes, it is staged, and he commits it. So he opens up the text editor, and the commit messages adds introductory sentence. He saves and closes it, and the file has been committed. So he goes back to the introduction, and he's thinking to himself, he could probably do better than this. So he takes away some text, and he adds, there was a dear little girl who was loved by everyone. And he thinks, yes, this is better than my initial implementation. I really, really like it. But I'm not sure if this is the final implementation. Perhaps I could do better, but I'm not certain. So he just saves and closes it, and he makes a whip commit. So whip commit is a convention, and it means a work in progress commit. This is, we are preserving this implementation of the introduction, and we could revert back to it if we want. So we have the peace of mind that we're preserving each implementation, and this is the whip commit. So Git status, the file has been modified, we stage it, and you could also provide the commit message inline on Git. And the way you do that is git commit, pass an in flag in the commit message itself. I don't suggest doing this for all of your commits because I think it encourages writing succinct, ill-formed, non-descriptive commit messages. But if you're writing a whip commit, it comes in really, really handy. It saves a step. So that's what he does. And the file is committed. He opens it up and he goes, how could it be better? So he adds, was loved by everyone who looked at her, but most of all by her grandmother. And he thinks to himself, yes, this is by far the best implementation of the introduction that I could think of. So he saves and closes it, and he enters Git status. The file has been modified. We stage it, and he commits it with the work in progress commit, and the file is committed. So that is the workflow number 3. Make whip commits, especially when you're developing complicated features. You know, think of a user should be able to sign in, and you have no idea how to implement it. This is especially true, like if you're exploring a feature or a solution. You might have 15 or 20 different commits that you have made, and you could revert back to any one of those at any time if you would like. So preserve those implementations. Okay. So we will spend a lot of time looking at Git history. As I mentioned, if we understand Git history, we could form a better mental model of Git and use it to our advantage. Okay, and Git provides a lot of ways to view history, which is not surprising. It's all about history and version control. So every time you see this image, this means we're going to dive in and look at Git history. Okay, so the command to look at one of the commands to look at history in Git is git log. I know this is a lot of text, but you don't need to know exactly what it means. But what this is a list of the commits that have happened in this Git repository thus far. The newest commits are at the top, the oldest commits are at the bottom. So our most recent commit was a whip commit. Prior to that was a whip commit. Prior to that was where we adds the introductory sentence commit, adds title and author, and then our initial commit. With each commit, it displays the author, and it displays the date, and it displays the commit message. Note, you have to configure the author, name, and email, which I have omitted in this presentation. But anyway, each of the commits display that information. Also, you'll see that each commit has this long 40-character string associated with it. And this is the unique identifier that Git uses internally to identify commits. And it's the way that we will use to identify commits with Git. That'll make more sense later on. And these are called SHAs, unique identifiers for each commit. So another way to view history is you could pass this patch flag. So you do git log patch, and what patch means is it displays more details about the commit. Specifically, it displays the patch, the diff associated with that commit. So any text in red was text that was removed in this commit, and any text in green was text that was added in this commit. So another way to view history. Just like we configured color, you could create aliases in Git. And I've omitted this configuration because it's long and it won't fit on the screen. But in short, the alias is LG. And when you hit LG, it displays history as this nice, quote, pretty graph. Again, the newest commits are at the top and the oldest commits are at the bottom. So our most recent commit, which is the whip commit, the commit message, the author, the date, the second most recent commit, the adds introductory sentence commit, adds title and author commit, and then our initial commit. So this is the view with which we are going to look at Git history for the rest of the presentation. Okay, so additionally, it displays some more information. And you see there's this word head that's tacked on that's associated with this commit. So what is head? Head is, or at least the way that I think of it, is the parent of the next commit. Okay, so you're thinking, what does that mean? So let's say we have a theoretical, this is a theoretical Git repository, and there are two commits. We have commit 1 and commit 2, and head is at commit 2. So it is the parent of the next commit. So if there was another commit, 3, commit 3 would occur on top of head. Head would be moved up to commit 3. If there was another commit, it would happen on top of head, and then head would be moved up to commit 4. So that's the way I think of head. There's also something called master here. And master is the branch. So branches are baked into Git. It's nothing special. So the default branch that you start on in Git is master. It just happens to be called master. There could be default branches named something other, but the default one that Git provides you is master. And it's usually the convention. Okay, so now looking at our Git history again. Master, so the point of this is we want to understand what branches contain different commits. And this history will become nuanced and more complicated, and we're going to look at this view to understand it. And it's really not that complicated once you understand how to read it. So master, the master branch, has all the commits in the repository. Okay. However, we have created an ugly history. And what do I mean by that? We have 3 commits that are about writing the introduction. So we have preserved each implementation of the introduction along the way, and we have 3 commits that are demonstrating that. I think a cleaner history would be if there was just 1 commit about writing the introduction. So I don't necessarily want to know the 15 different commits you use to get to the implementation. I want to know the implementation. That's not always the case, but a lot of times it is. And that is why we care about a clean history. It also helps when you do code reviews, if y'all do this. So I don't know if y'all recognize this guy, but this guy is Doc. He's from the Back of the Future. And he had this really cool car, and there was a clock tower and lightning. I don't remember all the details, but it all happened at the same time. And he was able, or I guess Michael J. Fox, whatever his character's name, he's able to go back in time and change history. I don't remember what he changed, but he did it. And so that's what we want to do with Git. So if you look at our history, we want to start rewriting history at the adds introductory sentence commit. So we simply walk down the graph that Git provides us, and we grab the SHA that's associated with this commit. For those who remember what the SHAs, well, they were 40 characters long when we did Git LG. This is a shorter representation. Git could use the first, it's smart enough to know that the first 4 characters of a Git commit are enough to identify the commit. It just happens to be that they are displaying 7, and then so that's the way I use. You'll see it here in a second. So you will copy that SHA, and then we'll use that here. There's a tool called Git Rebase, and this is the tool that allows you to rewrite history, and it has an interactive mode, and that'll make more sense in a second. And we say, hey, we want to start rewriting history at this SHA. And then you notice this little character here. It's not critical, but what this means is start rebasing at this SHA, not the child of this SHA. So if you didn't supply the character here, Git would start rebasing at the child of this SHA. Anyway, so it's just a nicety for me. Okay, so when Jacob hits enter, what will happen theoretically? If there's any people here on the Git core team or understand it super in depth, they might cringe when they look at this, but this is my understanding. So our theoretical Git history, we have 4 commits. Oldest commits at the bottom, newest commits at top, and head and master at commit 4. And we want to start rebasing at the second commit. So this is what would happen. Git pulls off commits 2, 3, and 4, puts them to the side, and makes a copy of them. So again, not crucially important to this presentation, but you could access these commits with git reflog. Anyway, so we want to rewrite history, combine all those commits into one, it melds them together, and it creates a new SHA. So actually rewriting history and the SHA for this commit is completely different. And it plops it on top of 1. So we have rewritten history. And again, apply head and master the references to this commit. And we have created a new base. Okay, so back to the command line, and Jacob hits enter. And this is the part that I just omitted. But what it'll do, it will open up your text editor and present you with this. So what does this mean? The commits that will be rebased are displayed to you here. The oldest commits are at the top, and the newest commits are at the bottom. This is opposite of how Git has been presenting the commits to us previously. Anyway, so we have both of our whip commits and the adds introductory sentence commit. And what we want to do is squish that whip commit in the previous one, and then squish that whip commit into the adds introductory sentence commit. So how do we do that? Git provides you different ways to rebase. So note, I'm almost just reading from the slide here. Git provides pretty good details of the commands that you could use. So you could reword a commit. You could use that commit but change the commit message. You could edit a commit. So during the rebase, it'll stop and you can actually change the code associated with that commit. You could squash the commit. So it's use this commit but meld it into the previous one. And that sounds a lot like what we want to do, but there's a better option, and it's called fix up. So it's like squash, but it discards that commits message and uses the previous commit message. So that's the one that we're going to choose. So up in the top left, we change the word pick to F, and we save it, and we close it, and boom, Git just rebased for us, and it tells us that it worked. Note, rebase could be very, very scary. It was scary to me for a long, long time. Know that you could always jam the Control-C and get out of it by entering Git Rebase abort. So if you freak out and don't know what's going on during the rebase, just enter Git Rebase abort, and then things will be reverted back to the state they were before you rebased. Okay, note, alarm should go off. Rewriting history is like, whoa, you should not do this. And I agree and disagree. So it's strong and it's powerful. It's like giving a toddler a very sharp lightsaber and go to daycare. You need to be careful with it. It does rewrite the history, and you should never rebase branches that are shared. And so we don't know what that means at this point. You might, but never rebase a branch that you have shared with somebody else, because they have a record of their history, and then you would be rewriting history when you rebased, and then you have 2 different versions of history and which one is right, and it'll cause a mess. Just believe me, don't do it. So we need to understand our Git history now that we've done this really great rebasing. So we look at history, and we have one commit about writing the introduction, and that's really, really great. You will note that there is a different SHA. So we started rebasing at the SHA 8979394, and this is not the SHA that is now associated with adds introductory sentence, which is ED04AE2. Okay, so workflow number 3 is, well, this is really a pro tip. Keep a clean history. I'm not necessarily concerned about the 15 different implementations that you use to get somewhere. I just want to know what the final implementation is. It helps with code reviews. I think it helps reveal the intent of a commit. So that's just my opinion. And you could use Rebase to help organize the commits if you haven't created a clean Git history along the way. Okay, so now it's 3 a.m. and Jacob is burning the midnight oil. So he opens up his text editor and he starts typing, and there is ALKJ, because his elbow hits the keyboard and he falls asleep. And he wakes up in a panic at like 7 o'clock in the morning. He enters Git status. Oh my goodness, I have done something, but I blacked out. I don't remember what it was. But we're just going to stage and commit it. So this is a command where you could stage a file and commit it in one go. So this just shortens the presentation a little bit. So we write our commit message, and he's like, I don't know, I added to the introductory sentence. So he adds the introductory sentence. He saves and closes it, and the commit was successful. Okay, so now Jacob looks at history with this patch so he could see what he did. And he sees that he did something absolutely insane and nonsensical. And he gets really, really mad because he committed something that he didn't intend to. I do this a lot, and it frustrates me. So Jacob is going to go back and fix that commit error. I like to have a clean history, which is evident, and so does Jacob. So he's going to go back and fix that commit. So what he needs to do is undo the last commit. Okay, so how do we do that? We need to understand Git history a little bit. So this is our history. This is our erroneous commit, where he fell asleep on the keyboard. And this is the previous commit, the commit prior to the error. So we want to move head and master backwards one commit. That's what we want to do. So the command for that is git reset head ~1. And what that means is move head back one commit. And then that means it works. No, it reverted the file back, but the changes were preserved, and that'll make sense in a second. So we look at LG, and we see that head has moved back to the commit prior to the error. And if you look back into our terminal history, you will see that that is where we wanted head and master to be moved back to. Okay, so now Jacob rewrites that erroneous sentence. So this is what I mean, the changes were still modified. The commit was still in a modified state, so his error is still available in the text editor. And he just erases it, and he adds, and there was nothing that she would not have given to the child. And he thinks that's awesome. So he saves and closes it. Now Git status, yes, it's modified. We stage it, and we commit it. But this time we commit it in a different way. When we commit it, we pass the verbose flag. So what does that mean? It means I want to see the patch when I'm writing my commit message. So he hits enter. And then now at the bottom of his commit message, it displays the patch, the changes that are associated with this commit. And the advantage is that it provides a nice summary for you when you're writing your commit message. You can make sure that you're committing what you intend, and you can write a very succinct and great commit message. And that's what he does. Adds an introductory sentence is his commit message. He saves and closes it, and it worked. So I suggest that you always commit with a verbose flag. So how can you do this? You could create a Git alias. So anytime you enter Git CI into the terminal, this is a global configuration. When you enter Git CI, it's going to execute commit verbose. So do that. So that's workflow number 4. Always verbose commit, always. It'll help you write better commit messages, and it'll reduce the errors that occur in your commit. Okay, so now Jacob writes the body of the Little Red Riding Hood, and he's going to use feature branches. So these are branches, and again, these are things that are baked in to Git. They're very lightweight. They're cheap. I suggest that you make them all the time, which is what I do. So Jacob enters the command git branch, and this lists all the branches in the repository. And then he sees that master is the branch that is listed. Remember that master is the default branch, is the one that Git gives us to us out of the box. And the little star means that we are on this branch. Okay, so we want to create a branch, and the command for that is up on the screen. But most notably, you have to supply a branch name. And there's a convention that I like to file. Note, this is a convention, not a requirement. I like to name my branches the author first name, the one who is writing it, followed by underscore, followed by author last name, followed by /. This is not a file path. It's just a string. And then a description of the branch. So that means the name of this branch would be Jacob underscore Grimm / body. Hits enter, and as I mentioned, it's a convention, and that means we created and switched to Jacob Grimm / body. Okay, so Jacob lists all the branches, and now there are two. There are master, and the little star signifies that we are on Jacob Grimm body branch. So great, we have two branches. It was that easy. Okay, so now we have a couple commits. We have a branch that we've created, and now let's look at our Git history to understand it. So we enter LG into the command line, and you'll see that head is at the adds to introductory sentence commit, and you'll see that master is at this commit, and you'll see that Jacob Grimm body is at this commit. What that means is master and Jacob Grimm body have all those commits. Those are included in its history. Okay, so imagine that you're working on a repository and you have 50, 20, 30 branches. Sometimes that's the case. And the only way to know which branch you're on is by entering git branch or git status, which also returns the branch name. There's a much easier way to do this. So there is a bash script that I have included a link to at the end of the files. But anyway, what the bash script does, it's included in the bash profile, and it displays the branch that you are currently on in the prompt. So we source that bash profile, which has the bash script, and it always displays the branch that you're on, which is Jacob Grimm / body. Okay, so Jacob opens up the little red riding hood.txt, and he writes the body, all in one big, enormous commit. And we save and close it, or he does, and he enters git status. Yes, it's modified, and then he stages it and commits it in one command. It opens up the text editor, and he wrote the story of the body. So that's the commit message, write story body. And he saves and closes it, and the commit was successful. So now our Git history is becoming more nuanced and complicated. So master and Jacob Grimm body have diverged. Jacob Grimm body has a commit that master does not. Okay, so how do we understand this? Or how does this look in Git history? It's really not that complicated. So we enter git log into the terminal, and we see that Jacob Grimm body is at the commit write story body. And we just walk back down the graph, and we see that it has all the commits in the repository. We see that master does not have the write story body commit, and it contains all the commits from adds introductory sentence down. So workflow number 5, I may have misnumbered these. Use feature branches when you're developing features or implementations because it allows you to silo that implementation. They're really cheap. If you don't like it, you could get rid of it. If you like it, keep it. We could incorporate it to wherever it needs to go later on. Isolate feature development. And the naming convention that we used makes it very easy to determine the author of the feature. So it overloads the name of the feature branch. Okay, so now Jacob Grimm has written the body, and that means he has finished the Jacob Grimm body branch. He's done with it. And he decides that it should be the story of the Little Red Riding Hood as we know it today. So he needs to incorporate that branch into master. So Jacob is currently on Jacob Grimm body branch. And we need to switch over to the master branch. The command for that is git checkout master, where master is the branch that you want to switch to. And then it worked, so now we are currently on the master branch. And we want to merge Jacob Grimm body into master. So git merge, name of the branch that you want to have merged into where you are. We are on master. Okay, so what would happen theoretically? Newest commits at the top, oldest commits at the bottom. We have 3 commits that are on master. So head and master are at commit 3. Jacob Grimm body have commits 4, 5, and 6. And Jacob Grimm body is at commit number 6. And we want to incorporate Jacob Grimm body into master. Remember, that's what we're doing. Because there is not a commit on top of head, what Git will do is simply pick up head and master, move it to the tip, of Jacob Grimm body, and then you pretty much have history as it is. It just straightens out the line and makes it very easy to read. So when Jacob hits enter, that's what happens. And you'll see that it merged it with a fast forward strategy. So what we just saw theoretically, that was a fast forward strategy, a merge with a fast forward strategy. Okay, so Git will fast forward merge anytime that is possible. Okay, so understanding Git history, now that we have merged a branch into master, let's look at it. Master and Jacob Grimm body are at write story body commit, and it has all the commits in the repository. So you can't easily tell what commits originated in Jacob Grimm body. So if you look at the history, there's no way you could easily tell without adding some additional Git commands or some configuration. You just don't know. Let's make it easy to determine which commits originated in Jacob Grimm body with something that I call merge bubbles. This isn't an official Git term. This is just what I call it. So you immediately ask, well, what is a merge bubble? And I say, wait a minute, because it's better described with a picture than me describing it to you with words. Okay, so to do that, first we need to undo the merge that Jacob just made. We need to undo the merge from Jacob Grimm body into master. So how do we do that? Again, we look at Git history, and we need to find the commit before the merge. So we walk back the history, and it is this commit here that adds the introductory sentence commit. We copy that shot of the clipboard, and the command is git reset hard. You don't really, it discards the changes. It doesn't keep them in a modified state. Completely get rid of them. Paste the SHA from the clipboard, the one that was associated with the commit that we want to reset to. And then it works. So it says head is now at that commit that we told it to be. So if you look at our history, you will see that head is now at the adds the introductory sentence commit. So is master. And Jacob Grimm body is at the write story body commit. So it's as if the merge never happened. But you still have access to it in Git through git reflog. Anyway, so to create the merge bubble, we need to again incorporate Jacob Grimm body into master. But this time we're going to create a merge bubble when we do it. Okay, so back to our merge command. We are on master, and we git merge Jacob Grimm body. That's the name of the branch. But we pass in an additional flag, which means, hey, don't use that fast forward strategy that you used last time. You use a different strategy, which is called a recursive strategy, which will create what I call a merge bubble. So what will happen theoretically? Back in theoretical land, we have 1, 2, 3 commits on master. This is the same implementation we saw earlier with the fast forward merge. Jacob Grimm body has commits 4, 5, and 6. So when the recursive merge happens, what it'll do is it'll create a merge commit up at the top to bring together the two branches. And then it'll move head and master to the tip. So you have this really nice merge bubble. And it's really easy to tell which commits originated from Jacob Grimm body. As I mentioned, that is a recursive strategy. So Jacob hits enter, and of course, it opens up the text editor. This is the merge commit. It automatically populates the commit message for you. You could change it if you would like. You save and close it, and it was successful. That means it worked, and it was merged with the recursive strategy. Okay, drum roll. Let's look at our Git history. What did it do? We look at our history, and we have this nice merge bubble. So we could easily tell that this commit originated on Jacob Grimm body. Which means that I like, for every merge bubble that I see, I like that to equate to a feature. So anytime I see a merge bubble, I'm like, this was a feature branch that somebody created and worked on. Okay, so understanding our history, master is at the merge commit, and it contains all the commits in the repository. Jacob Grimm body is covered up, unfortunately, write story body commit. It does not have the merge commit. It has the rest of the commits in the history. It does not have the merge commit. Okay, so when you merge a feature branch into master, always merge with a no fast forward strategy. This will ensure that you create this merge bubble. If you use GitHub, I think Bitbucket does this. Anytime you click merge on their GUI on the web, I believe it's going to merge with a no fast forward merge, so you always have that merge bubble. And as I mentioned, it makes it very easy to determine which feature branch a commit originated. Maybe you don't care, but I like to keep a clean Git history, so I do. Okay, so now Wilhelm Grimm has caught wind that Jacob has been working on this story solo. And he's a jealous older brother, and he wants to be a part of it. But he lives in Germany. And Jacob has since immigrated to Athens, Georgia, and he's part of a writers guild, and they don't know how to communicate. I recommend that you use email. So you package up all your commit code into a zip file and email it to them. I'm just kidding. Don't do that. There's something that is much better. Git has this notion of remotes. And what remotes are, they're remote repositories. They're versions of your project that are hosted on the internet or a network somewhere. There's really nothing special about them. Like I said, they're baked into Git. You could even have a remote established on your machine. So yes, you could be pushing to your own machine if you would like. And they could be configured to be read-only or read and write, however you like to configure it. The one that I'm most familiar with is GitHub. Okay, so Jacob Grimm creates a repository on GitHub, or creates an account on GitHub named J Grimm, and a repository named Fairy Tales. I made this up. There's apparently a J Grimm account. Her name is Julie, but I just wrote over my own. Okay, so when you create a repository, GitHub gives you this URL. This is the URL that you could use to communicate with your remote. So you copy and paste that to your clipboard. So back to our local machine. Jacob hits enter to display all the remotes that are configured with this local repository, and there are none, which is not surprising. We've not configured one. So let's configure one. So the command is git remote add a remote origin. Remember, this is how, or not remember, this is the name that we'll use to refer to GitHub, to the remote locally on our own machine. It could be Blue, it could be Dog, it could be Julie, but the convention is origin. Sometimes when you're working with Heroku, I don't know if y'all do that, but you might name it Heroku. Okay, and then the URL that's associated with your remote, which is what we copied from GitHub, you put it in there, and now you say, give me all the remotes configured with the repository, and you see that we have one called origin. So we want to move the code from our local machine to the remote. And how do we do that? The command is git push origin, which is the name of the remote. This is GitHub. And master. We want to push up our master branch. So we have our happy little computer that Jacob has on the bottom. He hits enter, and it pushes up all the code to GitHub. And all that means it works. You don't need to necessarily know what all that means. I don't. I just know it means it works. So we look on GitHub, and we see that there's a write story body commit on GitHub. Boom. It was that easy. We push code from our local machine up to GitHub, the remote. OK, so now our history is becoming more nuanced and more complicated, and it's actually not that complicated once you understand the history. So origin master and master. What is origin master? We haven't seen that before. So origin master is the master branch on the remote. Since we called it origin, it's saying, hey, the master branch on origin master. If we called it Julie or dog, it would say Julie master or dog master or like whatever, but we called it origin. So remember, we alias GitHub as origin, and that is origin master. So master on GitHub and master on a local machine have all the commits in the repository. Jacob Grimm body has write story body commits all the way down to the initial commit. Okay, so now we have this, Jacob wants to write an alternative ending. And it's what this whole presentation was built about, right? So that's why you came. You're like, what does the big bad ogre have to do with Little Red Riding Hood? Well, we will find out. So Jacob begins writing that alternative, very exciting ending. But he's going to create a feature branch when he does it. So he creates a branch called Jacob Grimm / Big Bad Ogre. That's his branch. That's a feature branch he's going to write the story on. So he creates it and switches over to it, and this is the magic. He does a search and replace of wolf and replaces with ogre. That's the entire implementation of the Big Bad Ogre ending. I hope I didn't let you down. So he finds every instance of wolf and replaces it with ogre, and he saves it, and he goes, wow, that's really, really great. Yes, the file's been modified. He stages it and commits it in one command, and the commit message is replace wolf with ogre. He saves and closes it, done. Okay, however, Wilhelm is off in Germany writing willy-nilly stuff. We have no idea what he's doing, but he pushed something up to GitHub, and he added to the introduction. A long time ago in a galaxy far, far away, it was a period of civil war. Rebel spaceships striking from a hidden base have won their first victory against the evil galactic empire. Also, once upon a time, there was a dear little girl who was loved by everyone. And Jacob loves it. I think it has really great potential. We'll see what happens, but I really like it. Okay, so now Jacob needs to update his copy of master with the additions that Wilhelm pushed to GitHub. So he needs to update master with origin master. So he checks out master because currently we're on Jacob Grimm body, Big Bad Ogre, excuse me. And the command to move code from your remote repo to your local repo is git pull origin master. Origin being the name of the remote, i.e. GitHub, and then the name of the branch that we want to pull down. So we move code from GitHub to our happy little computer on Jacob's desk, and it worked. Okay, so now understanding Git history. Again, told you we were going to do this a lot, but it's important. So we look at our history, and there are some additions. Jacob Grimm, Big Bad Ogre, the branch where he's replaced wolf with ogre, has all the commits in the repository. Actually, that's wrong. Sorry. Origin master and master has Galactic Empire, the story that Wilhelm pushed to origin master. So origin master and master have that commit and all the way down through the rest of the repository. And then way back when Jacob was writing Jacob Grimm body, it has the right story body commit all the way down to the initial commit. So Jacob finishes the Big Bad Ogre feature branch, and he hates it. It just didn't turn out the way that he wanted. So he never merged it into master. And then so the Little Red Riding Hood in the Big Bad Ogre alternative ending is lost with time. Y'all are the first folks who have ever seen it. So that's why it's not incorporated in the popular story as we know it. But Wilhelm made one more addition. So Jacob looks up on Origin Master on GitHub, and he sees that Wilhelm has placed his name as the primary author, just like an older brother, jealous older brother would. So what did we cover? We looked at what is Git. We looked at creating a Git repository. We looked at some basic workflows where a file goes from a modified state to staged to committed. We spent a lot of time understanding Git history because understanding Git history is really the key to unlocking the power, in my opinion, of Git. We want to leverage it to our advantage, so we spent a lot of time looking at Git history. We looked at a way to rewrite history. Whether or not that's a good idea or not is probably up to you and your organization. We use it a lot, so long as we haven't pushed it up to the remote and other people working on it, so do not rebase shared branches. We covered branches. We looked at different ways feature branches can be merged into master. And we looked at remotes, which allow us to collaborate with other folks in different locations. So these are the resources that I promised. Make sure you remember all these right now. They'll be available later. And that is the end of the presentation. So we have some more time. I don't know how much because I just closed Keynote. Some more minutes. How many more minutes do we have? 15. Okay, so I'll open it up for questions, comments. You were first?
When say that you have a Git
Can you speak up? I'm sorry.
say that you have a Git remote on your machine or your local server, does it have a GUI interface or is it just through Git commands that you can use?
So you're saying if you created a server, whether it be on, or excuse me, if you had a server where you installed Git and you wanted it to be the remote, or if you created a remote on your local machine, does it have a GUI with it? I think there is a GUI that comes out of the box. I don't use it, so I'm not a good person to address these questions. It's not like GitHub. It's not as sophisticated as GitHub. I think you could visually see the history as a graph and do some more interesting things. There are a lot of GUIs that you could use, which in my opinion are better than the default ones. GitHub provides one, which is really, really nice, and I use that on occasion. So yes and no, but there's lots of them out there. You are next.
Yeah, I don't exactly know how to ask the question, but when I work with older versioning systems, like Subversion, PDF, anyway, I mean, the whole philosophy was that we had a project where there were a group of us working on it. And so we viewed the versioning system as this was where we're going to have our gold copy of it.
Mm-hmm.
But when I watch your presentation of Git, it doesn't seem to have that same feel.
Okay, I'm going to reiterate the question so everybody else could hear it. So in her experience, which is a lot with Subversion and its predecessor, in her experience, the central server, there was a central server, and that was like the canonical golden standard for the repository. And she was questioning whether that exists in Git. I would say yes. Typically, master, which is going to exist on the remote somewhere, is typically your canonical golden example, the golden canonical branch that represents the state of the project. All the other feature branches are just different implementations. It's very common that master would be, perhaps your production branch. Maybe you have a staging branch where you create feature branches and then they're merged into staging and then the staging is merged into master. So a lot of times master is the canonical branch, the golden standard for the repository. But it doesn't have to be. It could be whatever branch you call it.
What about resolving differences? I mean, when we had a Subversion repository, you try to do something, you see with
Okay, so are you asking about conflicts, like merge conflicts? Okay, so she's asking what are Git, how does Git handle merge conflicts? They don't happen. I'm kidding, they do all the time. So you have to resolve them. If you have a feature branch that conflicts with master, perhaps somebody has pushed something to master and you've created a feature branch that is working on the exact same line that somebody just introduced to master, and you ask to merge it. Git will, during the merge process, it won't complete the merge, and it'll say, hey, these files have merge conflicts, and it allows you to go into the file itself and rectify which implementation should be merged. So you literally go to the file, delete this line, preserve this line, save, continue with the merge, and then that is how the merge conflict is resolved.
So you get when the file is the file that it gets you back showing the conflict.
Yeah. So you're kind of pause halfway through the merge process, rectify any conflicts, save them, commit them, bloop, continue with the merge, and then that's how that works.
Can you speak to tags and how they're different from branches?
No. I don't understand them well enough to feel confident in what I would tell you.
Okay.
I apologize, I came in a little bit late. What is Git? Does it run on Windows or Linux, or is it a command? Is it a piece of software that you buy?
So it is software, it's version control. It could run on Windows, Linux, or whatever. It's open source and it's free.
So it would be like you manage, let's say you have 5 developers working on a project, all writing different Java programs, but it's all one project. It would be a way to version control all those programs.
Yes, and allow your different developers to collaborate on that project.
Oh, so you were saying you should not rebase shared? So does that mean, am I wrong in thinking that if I was working on my own feature branch and I was working on it over a couple of days and I kept pushing it up to remote, but I'm the only one working on it, it would be okay to rebase it if no one else was using it?
Okay, so the question was, I brought up this big alarm like, hey, do not rebase commits that you have already pushed to origin. So that's not entirely true. So I think what you were saying is, let's say you have this feature branch that you have pushed up to origin, and you are the only one working on that feature branch. So should you rebase the commits that you've already pushed to origin in this feature branch, should you rebase those and push them back up to origin? I do that all the time, only because I'm confident, or only when I'm confident when I'm the only one working on the feature branch. Let's say that somebody else cloned that feature branch and was working on it and wrote some other implementation and pushed that up to your branch, and then you had already had that branch on your local machine and you rebase it and pushed it up. Git will say, hey, I can't push this up because there's a difference between origin and master for this feature branch, but you can make it. So let's say that you made it. You forced it, that is the command, force push to origin master for this feature branch. That person has a completely different history of that branch than you do. So it's like DocWick back in time and change everything, and it's different than it is today. So they're like completely two different histories. So to answer your question, if you're the only one and you are sure you're the only one working on that feature branch, sure, go ahead and do it. And I do it all the time. But if you have to be aware of the consequences, really communicate amongst your team. Just like, hey, I'm rebasing this branch a lot. Don't work on it. I'm sorry, can you speak up?
Maybe use like a fetch and a pull kind of one.
I'm sorry, I can't hear you.
Maybe use like a fetch and a pull. So instead of Git before we use like a stash. So rather than having to go with this, we have multiple people working on the same branch and on the same feature set. You have these two commands like a fetch and a pull kind of one.
Right. Okay. So the question he asked, the way I understand it is, what is git fetch and what is git pull? Like, what does that mean? So you have this remote repository, and the way that we move code from the remote to our local machine was git pull. Okay. So what git pull really does? Note that it's configurable. You can configure git to issue whatever commands that you want. It's really an alias for like, execute these commands, but out of the box, git pull does a git fetch, which moves all the code from the remote to your local machine, but it doesn't merge it into your branch that you're working on. If you just do a git fetch, it pulls the code down, and you have to manually merge in what you want into the branch that you're working on. Git pull does a git fetch and a git merge, so it pulls in all the code and merges it into your branch. So a lot of people will do a git fetch. They just want to see what the code is that they pull down before they merge it into their branch. But I didn't cover that in that presentation because I thought it was, I think, outside the scope of the level at which I wanted to speak.
In your example, do you git edit before any edits were actually made to the file and then committed it? Is there a benefit to staging early? Because typically in my workflow, I end up adding files right before commit. So I guess I'm asking, like, is it appropriate or is there a benefit to staging a file earlier than working on it and then commit it?
Okay. So I'm not sure I fully understand your question, but let's say you have a file that you just created it and you staged it, and then you continue working on that file.
I'm saying, like, the typical workflow is to just work on a bunch of files, and when you do a git status, they'll all show up red, and then you'll git add and then git commit.
That's what I usually do.
Okay. Because in your example, you actually you touch the file to make an empty file.
Well,
and
so
then work on it.
right. Well, you do git add to also initially tell Git to start tracking this file. So you have to add it and commit it, and then once you commit it, Git at that point is paying attention to it. If you just did git add, it would always remain red. You could continue working on it, but when you made a commit, it would just be the first commit would be everything that you have done to that file. So the command to initially tell Git to say, hey, start tracking this file is git add. But once a file has been modified, you want to stage it. The command is also git add, and it's stage, and then git commit. Does that answer your question?
I guess I wasn't aware that there was even this alternate state in between staging a file and then committing it. I usually just do both commands right at the same time.
Yeah, some people perhaps don't like staging. They just go from modify to commit. Any other questions in the back?
How difficult is it to, well, I've heard that if I understand that actually committing lines of code, like a single line of code, file is modified.
Right. Okay, so the question was, is it possible, or has he seen, or how difficult is it to have a file that perhaps, I don't know, has 20 changed lines and you want to commit line 5 and line 15? How hard is that to do and how easy is it to do? You could do that from the command line. If you do git add p, it'll stage what it's called hunks. But it leaves it up to Git to decide what a hunk is. So if you have two changed files, or excuse me, two lines that have been changed right on top of each other, Git will probably try to add those as a hunk. Perhaps you want those to be in separate commits. There are GUIs that allow you to more easily do that. I use the Mac version. I write on a Mac, and a lot of times if perhaps I've created a feature that should have been chopped up into 15 commits, and I haven't made a single commit, I could use the GUI just to click on the lines that I want to stage and then commit. So you could do it from the command line. It's clunky. GUIs provide a much easier way to do it. Perhaps there's a better way to do it from the command line that I'm not aware of, but I don't know it.
That the feature or the process that you just talked about, is that available in other repository tools or other utilities, or is that a Git feature where you can commit in stages?
So I don't know the details of the implementation. My guess is that if you could do it through a GUI, then Git provides you a way to do it, through its API. So to answer your question, yes, you could do it. Perhaps I just don't know how to do it. At the very least, the GUI allows me to do it. At least the GUI that I use.
So GitHub is a product that you purchase that runs the Git command?
GitHub is a company that really evolved around the idea of allowing different developers to collaborate on projects. So they allow you to create an account. It's free, or they have free and paid versions. But you could create a repository and allow people to push code up and pull code from that repository. So GitHub creates a remote for you for a repository. So anything that's free is public, and anybody could make commits to and pull down and all that. They also have a paid version where you could have private repositories. So that's just GitHub. There are other companies that have evolved around this. One that I've used is Bitbucket. So they do essentially the same thing as GitHub, but they have a different pay structure. Their pay structure is that it's close to this, so don't quote me on this, but you have X number of repositories that can be private, or a cap on how many members can be part of a repository that can be private, something like this. But the point is, you could have free private repositories. So if you're working on some super secret side project, with Git you would have to have a paid account. With Bitbucket you could have a free account, but within the confines of what they allow. You could also host your own with GitLab. So GitLab, there was a picture of it. I didn't speak about it when I was talking about remotes, but it is like GitHub, like Bitbucket. You can host it on your own server. You're in charge of all updates and all that. I've never set one up, but I have used it. And it's nice. It's really nice. All right, well, I hope you all enjoyed it. Looks like that was all the questions.